This is Algebra 1, Lesson 7.3, using linear combinations to solve linear systems, more often called the elimination method. We're using linear combinations to solve systems of equations. We're going to use them in real-life models on 411, beginning on page 411. First definition is a linear combination. In English, it says a linear combination of two equations is an equation obtained by adding one of the equations or a multiple of one of the equations to the other equation or a multiple of that. And we'll see what that means in just a minute. You're combining the two equations to eliminate one of the variables. Once one of them is eliminated, you can solve for the other one. Here is the first example. It says solve the linear system. Remember, we're using addition. We count addition and subtraction as the same thing. Because remember, addition and subtraction mean the same thing. It just means putting things together. If you're adding things that are positive, you count like addition. But if you're adding something that has a negative value, that's just like subtraction. So with this first system, it says 7x plus 2y equals negative 6, and 5x minus 2y equals 6. It says the equations are already arranged with like terms in columns. The first thing you're going to look for with the combination method or the elimination method is that your x's are stacked on top of your x's, your y's are stacked on top of your y's, and your constants are stacked on top of your constants. That's true. If they're not, which example number 3 is not in a couple of minutes, you're going to move one of the equations or both of them to stack them nice and neat. We know how to move things over from one side of the equation to the other side. All you have to do is the inverse operation. But these are neatly stacked on top of each other. So what you do is you combine, in order to eliminate, you combine your terms. 7x, and it would be a little neater looking if this was written this way, 7x plus 2y equals negative 6, and 5x minus 2y, because it says plus a negative value, equals positive 6. When you combine those two, 7x and 5x gives you 12x, and that's what it says over here. It's just kind of under the y. 12x. 2y and negative 2y eliminates. That's what you were trying to do when you put those two together. That's why we talked about opposite terms when we started this morning. And when you combine negative 6 and positive 6, you get 0. That just eliminates by coincidence. That wasn't the one we were trying to eliminate. So what you have is 12x is equal to 0. We know how to get x by itself. You divide both sides by 12, and 0 divided by anything is 0. So once you have x's value at 0, you substitute it back in. So substitute 0 for x. It says to do it in the first equation. Look back at your equations and determine which one you think would be the easiest one. It doesn't matter which form of which equation you use. There'll be 2 of them. Sometimes you'll have 4 equations written down because you might have to change 2 of the equations, which we'll do in a second. But it says to plug it back into the first equation. You know x's value is 0, so in place of 7x right here, 7 times 0, that eliminates that part. So what you have is 2y equals negative 6, and when you divide by 2 on both sides, you get y's value is negative 3. So you have x's value is 0, and y's value is negative 3. Remember, you write it as an ordered pair, x comma y. It says to check to see if 0, negative 3 works. Plug it into both equations. 0 times 7 is 0. 2 times negative 3 is negative 6. The top equation, negative 6, is equal to negative 6. Same thing with the bottom equation. 5 times 0, again, 0. Negative 2 times negative 3, a negative times a negative is a positive. 6 is equal to 6. It works with the second equation as well. So the solution is 0, negative 3. 0, negative 3. Okay, on the back, try this one. They're nice and neat and stacked on top of each other. The x's on top of the x's, the y's on top of the y's, the constants on top of the constants. Combine them. You should see one of the variables eliminate. Once it's eliminated, solve for the other and sub it back in. Take about a minute. Okay, let's take a look at it. Went a little bit better in a minute. You'll notice when you're doing this method, oftentimes, especially if it's set up nice and neat like this one is, it seems a whole lot faster than the substitution method. When we combine negative x and positive x, that's just like saying negative 1 plus 1, you get no more x's. You eliminated your x's. When you combine 2y and 6y, you get a positive 8y. And when you combine negative 8 and negative 16, you get negative 24. We all know how to solve for y at this point. It says 8 times y. You divide by it to cancel out the multiplication. If you do it to that side, you got to do it to this side. Y is equal to a negative divided by a positive is going to be a negative, and that divided by 8 is 3. So you have your value for y. It's negative 3. Decide which equation to plug it back in. There is no wrong answer. The only equation that you can't plug it back into is this one because there's no x value for you to use to solve it for. So as long as you have an x value, plug it into the one that you think looks easiest. I think that this one looks easier simply because there's a positive x. So if you plugged it into the other one, that's okay. Now you have to use the substitution method at this part. X plus 6 times, we got a new value for y. We just found out it's negative 3. Is equal to negative 16. Multiply 6 times negative 3, you get negative 18. So x minus that, because it says plus a negative means minus, equals negative 16. Undo minus 18 by adding it to both sides to get x by itself. And negative 16 plus 18 is going to be positive 2. X is equal to 2. So you have an x and a y value. Plug them both in to see if it's right. Negative x, negative 2 plus 2 times negative 3. That's going to be negative 2 minus 6. That is equal to negative 8. Do the same thing with the other equation. X's value is 2 plus 6 times negative 3 is negative 18. 2 plus negative 18 means 2 minus 18, which is equal to negative 16. You write this as an ordered pair, x comma y. You write it to say 2, negative 3. That's where they intersect each other. Now, this was the best case scenario. Your x's were stacked in columns, your y's were stacked in columns, your constants were stacked in columns, meaning things that don't have any variables, and you had opposites. You had x and you had negative x. For example, number 2, notice everything's stacked in columns again. X is on top of x, y on top of y, constants on top of constants, but you don't have opposite terms for this one. So what you need to do is you need to multiply or transform one or both equations. The first thing you want to do is you want to look at your multiples of 3 and 2 to see if we can eliminate those. We know that to get the smallest number that 3 and 2 both go into, or their least common multiple, is the number 6. So we can make one of those 6x, the other one negative 6x to eliminate them. Or you could look at your y's, negative 5 and positive 4. The smallest number that both of those go into is 20. So you can make that one of them positive 20, the other one negative 20. Okay. The example is choosing to make 3 and 2 turn into 6 and negative 6. So it says the equations are already arranged. You can get the coefficients of x to be opposites by multiplying the first equation by 2 and the second one by negative 3. So not only are you making them the same multiple, 6, you're making one of them positive, the other one negative. So what you are doing is distributing a 2 to everything in this set of parentheses. 2 times this is going to give you 6x. That's what you're trying to do. But you can't just multiply one term by 2. You have to distribute it to everything in the parentheses. And you're going to multiply this equation. You want 2 to become negative 6, so you're going to multiply this one times negative 3. Again, you can't just multiply it times this one. You have to multiply it by everything in the equation. When you do that, 2 times 3x is going to be 6x. 2 times negative 5y is negative 10y, and 2 times 15 is 30. When you do the same thing to the other equation, but you're multiplying by negative 3, 2x times negative 3 is negative 6x, 4y times negative 3 is negative 12y, and negative 1 times negative 3 is a positive 3. Notice how your system is set up now. Your x's are on top of your x's, your y's are on top of your y's, your constants are on top of your constants, and you have a set of opposite numbers in 6x and negative 6x. We did that on purpose to eliminate the x variable. Now when we combine them, 6x plus negative 6x or 6x minus 6x, this part right here will eliminate. It's gone. That's what we did that on purpose to get rid of x. Negative 10y minus 12y is negative 22y. 3 plus 3 is 33. So you have negative 22y is equal to 33. Now just solve for y by dividing by negative 22 on both sides. This divided by negative 22 and this divided by negative 22. So y is negative 1.5. We would have gotten, without making a decimal, we would have gotten negative 3 over 2 because we would have done, we would have simplified, and eventually I'll get to the right word, by taking 11 out of both terms, out of 33 and 22, to get negative 3 over 2, which does become negative 1.5 or 1.5. So once you have y's value, sub negative 1.5 in or plug it back in place of y. It says to sub it into equation number 2. Again, you could do it into either equation you want. Notice it went all the way back to the first form of equation number 2, not the transformed one, because that was bigger numbers. So 2x plus 4 times y is negative 1.5. So 4 times negative 3 is negative 12. Divided by 2 is going to be negative 6. So we have 2x minus 6, or 2x negative 6, is equal to negative 1. We know how to get x by itself. We add 6 to both sides. When you add 6 to both sides, I kind of put those two steps together. 2x minus 6 equals negative 1. When you add 6 to both sides, you get 2x equals positive 5. And when you divide by 2 on both sides, x's value is going to be 2.5, 2.5. That's the same thing as 2.5. Now you have a value for y and a value for x. Y's value is negative 1.5. X's value is 2.5. X comma y, 2.5, negative 1.5. Remember to write it. Don't do all of that work and then write your x and your y in the wrong spot. Make sure you write them as x comma y. So look for the easier one out of your x's or your y's to eliminate, and then multiply one or both equations by something in order to do that. Okay, so here's another example. Let's copy this one down on the back. 5x minus 4y equals 3. 2x plus 8y equals negative 2. Take about 20 seconds, see if you can decide which variable will be easier to eliminate, the x's or the y's. Okay, for this one, they're stacked on top of each other. X is on top of x's, y is on top of y's, constants on top of constants. But you don't have opposites. 5 and 2 are not opposite. Negative 4 and 8 are not opposite. We can make 5 and 2 into 10 and negative 10. Or we can do the easier version and make negative 4 into negative 8. That'll be the opposite of positive 8. So in this case, we don't have to transform both equations like the example. We only have to transform one of the equations by multiplying negative 4 by whatever we have to multiply it by to get it to become negative 8. We need to multiply it by 2. But you can't just multiply it times that to get negative 8y. You have to multiply it by every term in the equation. 2 times 5x, you distribute it, you get 10x. 2 times 3, you get 6. So now we have two equations, and it's easiest to draw a line to where you can separate to where you know which ones you're looking at. We're not looking at that top equation anymore. We're just looking at the bottom two. Eliminate one of the variables and then solve for the other. Take about a minute to do the rest of that. Okay, when we combine our x's, 2x combined with 10x is going to be 12x. When we combine 8y and negative 8y, we eliminated the y's. We get 0y. That's what we tried to do. That's the methods. That's why it's called the elimination method. And when we combine negative 2 and positive 6, we get positive 4. So now we have something that says 12x is equal to 4. Divide by 12 to get x by itself. Do the same to the other side. X is going to be equal to the number 4 goes into both itself once and into 12 3 times. So x is 1/3. Now you have the x coordinate. Now we need to find the y coordinate. Plug 1/3 into either of the 3 equations. We have 1, we have 2, we have 3. I would suggest against plugging it into the one that we made, 10x minus 8y equals 6, because look how big the numbers are compared to the other one. Plug it into the smaller numbers, or plug it into something that 1/3 is easy to find to make it easy for yourself. So if we plug it into this second equation, 2x plus 8y, it's going to become 2 times x is 1/3, plus 8 times y is 8y, equals negative 2. Notice all we did was plugged it in place of x, the new value we have for that. Multiplying straight across, 2 times 1 is 2, 1 times 3 is 3, 2/3, plus 8y equals negative 2. Get rid of 2/3 plus that by subtracting 2/3. If you subtract it on the left, subtract 2/3 on the right. Now what you have is fractions that need to be subtracted. So what we're dealing with is negative 2 over 1 minus 2 over 3. We need to create like denominators. 3 is the smallest number they're both going to go into. This one multiplies by 1, so this one doesn't change. It stays negative 2/3. The other equation, though, or the other fraction, needs to multiply by 3 to become 3. So this one multiplies by 3 as well to give you negative 6. So negative 6 minus 2 is going to be negative 8 over that common denominator 3. So negative 8 over 3 is what's on the right-hand side now. The left-hand side eliminates that part. So you have 8y equals negative 8/3. And then in order to get y by itself, you divide by 8. You divide the other side by 8. Remember, when you're dividing fractions like this, dividing this by 8 is the same thing as multiplying by the reciprocal. The reciprocal is multiplied by 1 over 8. So y equals negative 8 over 3. Notice you don't change the first fraction. You change division to multiplication. 8 over 1 becomes 1 over 8. And you could cross cancel the number 8. It goes into itself once, and into that one, negative 1. So negative 1 times 1, y's value is negative 1, and 3 times 1 will be 3. So your y value is negative 1/3. Your x value is positive 1/3. The solution, where they're going to intersect, if you were to graph them, will be at 1/3, negative 1/3. We're going to skip the checkpoint. Example number 3 is arranging like terms in columns. 3y equals negative 6 minus 4x. 7x plus 3y equals negative 15. Notice again, your x's and y's are not on top of each other. Your constants are not on top of each other. So you have to move one or both equations to make them stack on top of each other. Probably just one of the equations. So what we're going to do is we're going to bring this negative 4x. We know if it's negative 4x on the right, when we bring it over to the left, it becomes positive 4x. We have 3y already on the left side of the equation. Notice that one doesn't move. It stays positive 3y. And we have negative 6x already on the right side of the equation. So the only term we had to move was the negative 4x, and it became positive 4x. Now they're stacked on top of each other here. 4x plus 3y equals negative 6. 7x plus 3y equals negative 15. That's good. They're stacked on top of each other. But now it's like example number 2. You don't have like terms. We have two things that are very close to being opposites, not like terms a second ago, opposites. We have 3y and 3y. So let's make one of them into a negative to where we can cancel out the y's. So it says you can get the coefficients of y to be opposite by multiplying the second equation by negative 1. You could have multiplied the first equation and been just as good. But you can't just multiply this one. Remember, you have to multiply it by every term. You have to distribute it to every one. So 7x times negative 1 is negative 7x. 7x times 3y is negative 3y. 7x times negative 1 times negative 15 is positive 15. Now everything's stacked on top of each other. Everything is, and we have opposites, 3y and negative 3y. Notice when we put those two together, they eliminate and go away. 4x minus 7x is negative 3x. And negative 6 plus 15 is positive 9. Divide by negative 3 on both sides, and x's value is negative 3. Plug negative 3 back into one of the equations. Says to do it in the second equation. 7 times negative 3 is negative 21 plus 3y is equal to negative 15. Add 21 to both sides. It would look like this. 3y equals 6, and then when you divide by 3 on both sides, you get y's value is 2. So you have x's value and you have y's value. So plug them, put them into an x comma y ordered pair. Negative 3, 2.